Hello guys, welcome back to my channel. Memo on African motives. Still working on mathematics and tools. So in this platform we shall have the question paper which was actually written in July 2018, which is an X paper. So we shall actually work on this and see how we ask these questions and how we're supposed to answer the given questions. So remember, you'll be having the instructions and the information, which is important, and mostly it's all about showing all your working, and also the issue of the degree of accuracy, which is to give your answers to 3 decimal places and so forth. And you must also write in a neat way. Your work should be at least in a neat way. So let us just rush through the question. We are asked to simplify on question Y each of the following expressions without, take note, without the use of a calculator. Show all steps. So we are not allowed to use a calculator there, but we are then required to show all the steps. So this is what we have here. Let's see how we are supposed to answer this typical question. So if you are to cross-check here, we've got 81 and 3 to the exponent of 2, which is these two. We can at least write them in the same base, which is of 3. Remember, 81 is same as 3 to the exponent of 4. So that means you shall have 3 to the exponent of 2 over 3 to the exponent of 4, like this. And as we know that when we are dividing the bases which are the same like this, we subtract the exponent. So it's going to be 2 minus 4, which is 3 to the exponent of negative 2. So we shall have 3 to the exponent of negative 2. We do the same for e. We are dividing, so we're going to subtract. So it's e to the exponent of negative 2 minus the exponent here, which is minus 4, like this. So take note, it's minus and minus, which is a plus. So, or you can just use your calculator, of which is going to be minus 2 plus 4, which is 2. So you're going to have e to the exponent of 2. You do the same for f. This is same as 1. So it's f to the exponent of 1 minus 3. So it will be 1 minus 3, which is minus 2. So you've got f to the exponent of negative 2. Then this is minus 5 minus 3. So it's g to the exponent of minus 5 minus 3, which is negative 8. So it's g to the exponent of negative 8, like that. So as we know that from our laws of exponents, whenever we've got a negative, we can write this as 1 over. So this can be everything over, but e is carrying a positive, so it's going to be written on top like this. Then all these terms we can write them down. So it's going to be 3 to the exponent of 2, all right, over f to the exponent of 2, g to the exponent of 8. You now remove the negative that are there by writing them over the denominator like that. But we know that 3 to the exponent of 2, that one is 9. 3 times 3, that is 9. So it's going to be 9f squared g to the exponent of 8, like this. So that is what we are going to have there as our final answer. So as you can see, guys, that's how they ask these questions, and that's what you are supposed to do. In this case, it was just 2 marks, and you can just leave at any stage. Then on 1.12, again, we are given a log to simplify or to evaluate without using a calculator there. So I actually wrote this down here. So this is what we have, guys. Remember, logarithm, you answer them according to the question that you're given. It's not like you have a directive way of answering logarithms. No, you answer them according to the way that you're given. Here I can choose to write this in terms of the same base here. That's gonna be 3 log in terms of base 8. 64 is same as 8 to the exponent of 2 in base 8. minus 64 in terms of 2, this is going to be log 2 to the exponent of 6 in base 2, 2 to the exponent of 6, that is 64, minus log this 2041 in terms of 7. So you have to try 7 to the exponent of 1 to the exponent of 2 to the exponent of 3 until you obtain 2041, 2401, which is going to occur at 7 to the exponent of 4 in base 7. All right, and everything over log 1000, this one we actually know that this is 3. Remember guys, I told you that from your logarithms, logarithm of 1 is 0, logarithm of 10 is 1, logarithm of 100 is 2, so it means logarithm of 1000 is 3. The number of zeros is the answer that you're going to have. So plus, we do the same here, 8 in terms of 2, so you're going to have 2 log 8 is going to be 2 to the exponent of 3 in base 2. Why are we writing in terms of the same numbers like this? We want to achieve this concept of log a base a, which gives us a 1. Okay, so once this condition is there, it means we have a 1. So we are going to drop the exponent here because this is an exponent. Remember, when you have log, you're going to multiply. So it's 3 times 2, which is 6. And we have got log 8 base 8. Minus, you drop the exponent here, which is 6 and 1. So it's 6 times 1, which is 6 log 2 base 2. You do the same here, minus, you drop the exponent here. So it's going to be 4 log, you remain with 7 base 7. Everything over, we do the same here, it's going to be 3 plus, we drop the exponent here. So it's 3 times 2, which is 6 log 2 base 2, like that. All right, so that's what you're going to have at that stage. And as you can see, we have managed to write our logarithm in this format of log a base a, which gives us a 1. So that means this whole part here is going to give us a 1. This whole part, that's a 1. So it's 6 times 1, which is 6, minus the same thing here. This is a 1, so it's 6 times 1, which is 6, minus the same here. This is a 1, so it's 4 times 1, which is 4, over 3 plus the same here, log 2 base 2, that's a 1, so it's going to be 1 times 6, which is 6, because when the number and the base are the same, you obtain a 1. So as you can see, 6 minus 6, that's a 0, 0 minus 4, which is minus 4, over 3 plus 6, which is actually 9, or you can now just simplify that one direct at once. So that is what we had, guys, from this our concept of logarithm, the stages of conversion, until you obtain a log that you can actually cancel out. These are the stages that they require you to apply or to do there. Then on 1.13 we are also given a log, all right, that is 3 marks, again a log like that. So here let's see what we have. As we can see, we can have log 189 in base 3 minus, all right, what can we do in this case? Remember that to the exponent of a negative 1 from our laws of exponents, it means 1 over. So this can be written as 1 over log 3 base 7. All right. And we know that from our laws of exponents, we have got a logarithm, we've got 1 over log a base b, like this, which is equal to log b base a. Whenever you're given 1 over, you interchange these two. So it's going to be log b base a. So you interchange the two. So this means that I'm going to be left with minus, since I'm having 1 over already, and it's going to be like this. So it's going to give me log. I interchange these two numbers. That is to remove this 1 over. So I'm going to interchange these two numbers. So it's going to be 7 base 3. take note, you interchange the numbers. So like this and this, they are equal. What we simply say is that log b base a is equal to log 1 over log a base b, like this. So when you are given 1 over, you can write it as a normal log like this, but you interchange these two. That is the concept. All right. So as we can see, we are now having a normal condition of logarithms which are subtracting and the bases are the same. And we know that when the bases are the same, you divide the numbers. So it's going to be 189 over 7 in base 3. All right. Which law do we use here? That is log m minus log n, which can give us log m over n, or it can be a and b, whatever that you have to divide. So 189 divided by 7, you are going to obtain 27 there in base 3. All right. But still, can we say this is it? Can we leave our answer at this stage? No, we can't. What can we do? We can simplify further. Remember that concept of log a base a, which gives us 1. So we can write 27 in terms of 3, which is 27 in terms of 3 is 3 to the exponent of 3 in base 3. So this is going to be 3 log. Remember, you have to multiply by the exponent. You drop the exponent, which is 3 log 3 base 3. And as long we have got this condition, we say this is going to give us a 1. So it's 3 times 1, which is 3. So our final answer there is just going to be a normal number, which is 3, without any logarithm there. So these are the stages that you were supposed to take or to apply in order to have that resultant there. So that is how they can ask these questions, and you have to be very, very careful the way you attempt the question. Okay, the other one, it's 1.22, which is a log. Okay, this one I didn't write it down, I don't know why. So which is 3, so it's like this, 1.21, sorry, which is 3x to the exponent of 3 over 2 is equal to 24, like this. All right, so there we've got 3 marks to solve for x. This time we are asked to solve for x. So to solve is to find the value of the unknown, which is the x. If we are to cross-check, this 3 is multiplying and it has nothing to do with this x, so we can actually just choose to divide by it so that we can have x to the exponent of 3 over 2, which is equal to 24 divided by 3, which is 8. All right. Remember how you remove an exponent, because the x is the base, so you need to remove the exponent, which is 3 over 2. So what you do is that you find the inverse of the exponent, which is 3 over 2. And I told you that the inverse, simply you have to interchange the two numbers. So it's going to be 2 over 3, like this. That is the inverse. So you multiply both sides by the inverse. So it's going to be x to the exponent of 3 over 2 by the inverse, which is 2 over 3. So you just interchange the numbers, okay, which is equal to 8, which is the same as 8. We know that in terms of 2 in its simplest form is same as 2 to the exponent of 3. Okay, so it's going to be raised to the exponent of the inverse, which is 2 over 3. So the inverse of this is the one that you use also on the right hand side. Whatever you do on the left hand side must be done on the right hand side. That is when you are solving. Okay, so since that is the concept, if we are to multiply this, definitely we are going to obtain 1 x to the exponent of 1, which is this, and this can cancel. We're going to have 2 to the exponent of 2. So x to the exponent of 1, that is x. 2 to the exponent of 2, that is 2 times 2, which is 4. So our x in this case is going to be a 4. That is what we were given there. Our x is going to be a 4. Then let's see another part. We have given a logarithm to solve, and this is a log that we are solving, which is log x base 3 plus log this is x minus 2 in base 3 again, and this is going to give us a 1. So this time we have got an advantage. Why? Because the bases are actually the same. So you know that when you are adding and the bases are the same, you multiply the numbers. Log a plus log b, which is equal to log ab. You multiply the two numbers there. So that's going to be log x times x minus 2. You multiply this and this. This is your a, this is your b. A times b in the same base, which is base 3, which is going to give us a 1. All right. So you are at this stage. Remember, you want to solve for x. So the only thing that you're going to do is to convert from log form to index form using this concept. Remember, I told you that log a base b is equal to c can be written as a is equal to b to the exponent of c, like this. So that means this is your a, this is your b, this is your c. So it's a, this whole part here, x into x minus 2, which is your a, is equal to b to the exponent, which is 3 to the exponent of 1. So you're going to have something like this. So this is now exponential form, which is easier for you to solve. Or what you could have done is you can do this. Log x into x minus 2 in base 3 is equal to, you can change this one, remember, you can change this one into a log because you are guided that you are in base 3. And remember from what I was just what I was saying before, that the logarithm of a in base a gives us 1. So since we are in base 3, for us to obtain 1, it is going to be log 3 base 3, because the number and the base should be the same. So what we are simply doing is to write a 1 in terms of a log, so that we can cancel the log and the log this one. So it means this one, x into x minus 2, like this, is equal to 3. So as you can see, this stage and this stage are the same, but this one we did it by converting to exponential form. This one you can do it by converting all to log form. Then you can cancel the log base because they are the same. Then you equate these two, so it's one and the same thing, as x into x minus 2 is equal to 3 to the exponent of 1 is 3. So you have to solve the equation. But how are you going to solve this equation? Because this equation and this equation is just one and the same. But how can we solve this type of an equation, guys? This is a quadratic, because if you are to expand this, we're going to have x squared, x and minus 2, which is minus 2x. We transpose this to the other side so that we are going to have the format of the quadratic equation, this one, which gives us a 0 on one side of the equation. That is why we have to transpose. So you can do it by factorization, by quadratic formula, depends with what you want. But since the coefficient of x squared is 1, I'm going to just have my x and my x there. All right. So what are the factors of minus 3 that we are going to add to get minus 2? Factors of minus 3, that's minus 3 and 1, isn't it? Minus 3 and 1, because if you multiply this, that's minus 3. If we add, that's minus 2. So you're going to have minus 3 plus 1. So definitely x is equal to 3, or x is equal to minus 3 to that one, that's plus 3, by plus 1 to that side is going to be minus 1. But we are working with a log here, guys. Let's get back here. If we are to substitute 3, this is going to be like log 3 base 3. Yes, it makes sense. 3 minus 2 is going to be log 1 base 3. But if we substitute minus 1, look at this stage, it's going to be log minus 1 in base 3, of which this does not exist in math. It's math error, this one, which means it's invalid. It's not exact. It's not exact, like it's an infinity. So our x cannot be a negative 1. So therefore our x is going to be 3. All right. So that's what we are going to have here. Then make C to be the subject of the formula. We are given to make C to be the subject of the formula on this part. Let's just write it down instead of doing it on the paper. Let me just do it here. This is 2 pi square root of LC, and we want to make C to be the subject. Okay, so the first thing, we know that this is actually same as 1, so you can at least cross multiply. That's f times this, which is going to be 2 pi f square root of LC. You just combine these two, which is equal to 1 times 1, which is 1. All right, take note, we want to make C the subject, but take note it's bounded by a square root. So before you get rid of the square root, you can maybe remove this 2 pi f. So you can just maybe divide by 2 pi f both sides. So this is gonna cancel. So you've got the square root of LC, which is equal to 1 over 2 pi f. All right, now you can remove the square root. It's easier for you now to remove the square root because you can just square both sides. Remember how you remove your square root, you square both sides. So the moment I square both sides, I'm going to be left with LC, okay, because automatically this removed, which is equal to this square is going to affect everything here. So it's 1 squared like this, which is going to be 1 over 2 squared, this one, which is going to be 4. Everything is going to be affected, so it's 4. Then pi squared, f also squared, everything, because it's to the exponent of 2. All right, now this is it. I want to make LC to be the subject. Remember, I want to make C, and this L is doing nothing, but it's multiplying. So I'm just going to divide by L, so this can cancel. I'm left with C. So therefore C is equal to 1 over 4 pi, this whatever that we have there. So it's 4 pi squared f squared L, like that. So that is what we are going to have as our C, because we want a C, so you can simply divide like that. And your C will be the subject of the given formula. All right, then on question 2, so as you can see there's the total of 18, and the question 2 we are then given the expressions, this one, then 2.11 is fully factorize each of the given expressions. All right, so what do we have, guys, on the first one here? As we can see, it's a squared plus 7a minus 18. So there we can just put our two brackets direct, a and a, because the coefficient here is 1. So what are the factors of negative 18 that we can add to get plus 7? So this is 9 and minus 2. If we multiply and add, this is, yes, 9 times minus 2, it's minus 18. If we add, it's 7. So it's a plus 9, a minus 2. All right, what about here? This is difference of two squares. Remember what I always say, guys, that you are supposed to write it like this in terms of squares. So this is going to be 2 squared m squared minus 3 squared y squared, like that. So you've got 2m and 3y, which are being raised to the exponent of 2. So you've got 2m and 3y. So one is going to add, another one is going to subtract, like that. All right, then what about this one? Do we have anything common here? Yes, we've got m is common, so you can factor m here. That's 2m squared divided by m, which is 2m. That's 2m. That's 2m. Then m and m, you're going to be left with minus 3y, like this. So this one, that's what you're going to have. As you can see, it's just 3 marks, which means 1 1 1 1 1, like that. Then on 2.12, then give the lowest common multiple, which is the LCM of the 3 expressions, and you've got 3 marks for that, for the LCM. And remember, I told you guys that the LCM, you have to take each and every term which is present, each and every term which is given. Okay, so you have to take all the terms. All right, so as you can see outside the bracket there is m, So you can start with that m which is outside of the brackets, then we move on to the brackets. We have got this bracket of 2m minus y, this one, which is the same as this one. So you just write it once because it's occurring, it has got the same value or the same exponent here. So you just write it once, okay? So this is going to be 2m minus 3y like this. And we've got this of 2m plus 3y and these two brackets also. So you're going to just write those ones as they are. That's a plus. So the order of the brackets does not matter. As long the brackets are all here, it's fine. So the order does not matter to say I'm going to start with this bracket or I'm going to start with this bracket. The order does not matter. What matters is that all the brackets are here. That is what matters. All right. Then on 2.13, which is the HCF now. So HCF, remember, it's supposed to be common throughout. It's supposed to be common throughout. But here we do not have such a consideration that is common throughout, because with this bracket we do not have it anyway. Yes, this bracket is here and here, but we do not have it here, so it's not common. This bracket is just found here, this m is just found here, so we do not have any common term that is found throughout. So what is then our highest common factor? Our highest common factor is going to be 1. 1 is common throughout, even like that. So your HCF is just going to be a 1, not a 0. No, 1 is the highest common factor. Then on 2.2, that is we're asked to simplify each of the following. So there it's all about your factorization. That is what you're supposed to be very, very careful with. So let's just try and factorize, guys, and see what we have here. So here the coefficient of x squared is 1, so we're just gonna put two brackets direct, okay, over. So remember, we have to focus with them. Let me just write it here. If we focus with negative 12 here, what are the factors of negative 12 which are going to give us minus 1? Okay, so we need factors of negative 12 which are going to give us negative 1. So negative 12, we have got negative 4 and 3, isn't it? If you multiply, it's minus 12. If we add, it's minus 1. So we are going to have x minus 4, x minus 4, x plus 3. Yeah, we said x plus 4 and x plus 3 there. All right, we have got the same thing here. The coefficient of x squared is 1, so we need factors of what? Negative 10, which will give us negative 2. That's negative 5 and 2. Yeah, if you multiply this, that's negative 10. If we add, that's negative 3. So you've got x minus 5, x plus 2. Okay, here you are dividing, so you're going to multiply. The moment you multiply, remember, you have to interchange this. All right, so you interchange the second fraction, which means this x squared minus 2x minus 8 is the one that is going to be written on top this one, because you are now multiplying. So this one is the one that we are going to write on top. So it's the one that we are going to factorize now. So here the coefficient of x squared is 1. So we've got negative 8, which is the factors of negative 8 is negative 4 and 2. Now, if we multiply this, that's negative 8. If we add, that's negative 2. So you've got minus 4 plus 2. So remember, we said this is going to be written on top and this is going to be written down here. So this is the one that you are going to factorize down. The moment you multiply, that's what you do. So you've got x and x. So what are the factors of 20? That will give us negative 9. So factors of 20, that's minus 5 and minus 4. Remember, 5 and 4 gives us 9, but this one gives us minus 9. So it's minus 5 and minus 4, okay, times this one is already simplified. You just write it as it is like that. So as long you have managed to factorize like this, guys, then you can cancel as long it is the numerator and the denominator. So the relationship is between the numerator and the denominator. Like this, x minus 5 is in the denominator, this is in the numerator. All right, we have got x plus 3 here in the numerator, x plus 3 in the denominator here. Which else we have got this x minus 2 and x minus 4 x minus 4 and x minus 4. We have got x plus 2, as long as the numerator and what the denominator. So as you can see, these two, they can't cancel each other. You can't cancel. If it is possible for us to cancel here, so it's just gonna rewrite as they are, which is x minus 4 over x minus 5. So you can put brackets or you can just write it like that. So as you can see, guys, whenever you are multiplying, the concept is all about how you are going to factorize and arrange your fractions so that you'll be able to cancel them in that manner. But when you are adding like this, you have to maintain or you have to keep the denominators. Okay, whenever you are adding, you have to maintain or you have to keep the denominators. So what am I trying to say? I'm trying to say that if we are given something like this, we have to maintain our denominators here. So let's factorize, then we see what we are going to have. So the coefficient of x squared here is 1, so you can do direct factorization. Remember, x and x. So we have got minus 4 here. So what are the factors of minus 4 that we are going to add to get 3? So that's 4 and negative 1. Because if we say minus 4 and 1 like this, yes, we are going to obtain minus 4, but if we add, this is going to give us minus 3. But we want something that gives us plus 3. So 4 plus 1 is plus 3. So it's 4 and minus 1. So it's x plus 4, x minus 1, okay, plus 4 over, do the same here. As you can see, the coefficient of x squared is 1. So you've got x and x there. So what are the factors of 3 which we are going to add to get minus 4? So we need factors of 3, which is minus 3 and minus 1, because this is minus 4, so it's supposed to be negative. 3 and 1, they are going to give us positive 4, not negative 4, so this one is wrong. So it's minus 3 and minus 1. All right. So remember, when you are adding or subtracting, you keep the denominator. You don't throw away these denominators, you keep them. So you are going to find the LCD, which is the lowest common multiple of all the denominators here. So you take the LCM. Remember, LCM, you take everything. X plus 4. All right. X minus 1 is the same as here, so you just write it once. X minus 1, x minus 3. That is your LCD or your LCM. Then you are going to divide LCD, divide by the denominator here. So if we divide, so you just assume dividing or cancelling. So as you can see, this and this will cancel because these two are the same. So you're going to be left with x minus 3. So you assume cancelling, but you don't cancel. So you're going to be left with x minus 2, which you multiply with these 2. So it's going to be 2 into x minus 3 like this, plus 4 multiplied by, as we can see here, x minus 3 will cancel and x minus 1 will cancel, which means these 2 will cancel. You're going to be left with x plus 4. So it will be x plus 4 like this. So you assume as if you are cancelling, but you do not cancel. All right, then at this stage you can expand your brackets, collect like terms. So 2 times x, we've got 2x, 2 times minus 3, which is minus 6. Okay, 4 times x, which is plus 4x, 4 times 4, which is 16. So you have to multiply everything. Then the brackets as they are, which is x plus 4, x minus 1 into x minus 3 like this. All right, so That's it, guys. We can collect like terms possible. They are, this is 2x and 4x, so 2 plus 4, 6x minus 6 plus 16, 7, 16 minus 6, which is what? Which is 10. So that's gonna be plus 10 everything over x plus 4 into x minus 1 into x minus 3, like that. All right, so you can actually factor out here. As you can see, 2 is common, which means you're going to be left with 6x divided by 2, which is 3x plus 10 divided by 2, which is 5. Why do we have to factorize here? Because sometimes you can have a condition like where you will have brackets which are the same, then you have to cancel them. But in this case, yeah, we do not have such. So which means even if we were to leave our answer at this stage, it was fine. So but you have to factorize because somehow you do not know whether it's going to cancel or it's not, and you do not factorize, maybe it was going to cancel. So you have to cancel out if it is possible, but if not, then you have to just leave it like that. All right, so that's what we had. And on 2.3 we are then given to fully factorize each of the following expressions, which is 2.31. so we are given 20x squared minus x minus 1. So remember, guys, whenever you are working with quadratic expressions like this, as you can see, the coefficient of x squared is not a 1, it's a number. So you have to multiply the first term and the last term, which is 20 times minus 1, that's minus 20x squared. So take note about this. You're going to do the longer way or the longer procedure where you're going to find factors of minus 20x squared, which you are going to add to get this middle term, which is minus x. So what are these factors of minus 20? As we can see, 20, there's something that has to do with 5x and 4x there. But how are we going to arrange these numbers? Because we need a negative x. So we shall have this as minus 5x. Okay. If we multiply these two, we obtain minus 20. If we add minus 5 plus 4, we obtain minus 1x. So these are the two numbers that we are going to replace into the middle term here. You substitute them into the middle term. So what am I trying to say? You're going to write this as 20x squared. You replace here with these two numbers, these ones, which is minus 5x plus 4x minus 1. So this part, these are the two numbers, then minus 1, just as it was. Then you've got 1, 2, 3, 4 terms. So you're going to group them into 2 like this. Group them into 2. You factor out what is common for the first 2 terms here, which is going to be 5x. Okay, that's our highest common factor. So 20x squared divided by 5x, that's 20 divided by 5, which is 4x, minus 5 divided by 5, which is actually minus 1, because as you can see, this will cancel, you're going to be left with minus 1. And already here you are left with 4x minus 1. As you can see, this part and this part are actually the same. So what are you going to factor out so that it remains the same? Which means you're just going to factor out a plus 1 so that it remains as 4x minus 1. Remember, when you are doing this method, you must make sure that these two brackets are the same so that you are going to factor out that common bracket, and which is 4x plus 1. And once you factor out this, you're going to be left with 5x, and here you're going to be left with plus 1. You write them in another bracket. So that is to factorize. As long as the coefficient of x squared is not a 1, you have to do it the longer way. And the longer way, you have to know the procedure. That is the steps that you're going to take when applying this longer way. But that is what you had. Anyways, and also to factorize on 2.23, that one, let's just see what type of an expression or was that. And this is 27y squared, like that. Okay, so as we can see here, this one does not make sense at all. what can we do? We can see that on top here, this is 3, this is 27, so you can factor out 3. 3 is common. So if you factor out 3 here, if you remove this 3, it's just like 3 divided by 3, you're going to be left with 1 over 64 minus 27 divided by 3, which is 9y squared, like this. So at that stage, try to express it in terms of perfect squares so that we try our difference of two squares. Remember our x squared minus y squared, which gives us x plus y into x minus y, like this. So 1 over 64 can be written as 1 over 8 to the exponent of 2 minus 9 can be written as 3 to the exponent of 2. Already this y is raised to the exponent of 2. So as you can see, it's a difference of two squares because each term can be raised to the exponent of 2. And whatever raised to the exponent of 2 is this 1 over 8 and this 3y, this one. So it's going to be plus 3y. Remember, one bracket adds, another bracket is going to subtract, like this. So that is the concept of difference of two squares. So guys, difference of two squares is actually nothing. As long you can write your numbers in terms of squares like this, then everything is clear. So that's how that's how you're supposed to answer this question. Then on question number 3, actually this question, it didn't like make sense to me. Actually what happened here, it was actually the way that it was asked, it was actually wrong, because then Peter gave a quarter of his money to Morris and half of to Ayanda. Ayanda received 35 rand less than Morris. Okay, how much did Peter have originally? Okay, let's just do this and maybe it can make sense later on. Let's start with Peter. Let Peter's amount be x, because it's the one that is giving people their money, so let it be x rand here. So this is the amount for Peter, and he gave a quarter. A quarter means 1 over 4, like this, to Morris. So Morris got 1 over 4. So this is Morris with 1 over 4 x. So it's 1 over 4 of this, which is 1 over 4x, and half, 1/2, which means 1 over half to Ayanda, and half of what? Of x. So Ayanda received half x, which is half x rand. Then the question is, Ayanda received 35 less than Morris. 35 less than more. If you are to calculate with this condition, the way that it was asked there, the answer is not going to work out properly. But the statement, if it is vice versa, to say that Ayanda, this Ayanda in this case, she received 35 more, then it was going to make sense, not 35 less. You're going to see with the answer that you're going to get that it doesn't make sense at all. So this was supposed to be more, so that your equation is going to be half x minus 35, which is equal to 1 over 4x. So you formulate from the amount of Ayanda. All right, so by doing so, you can solve your equation by collecting like terms, depending with the way that you're gonna do it. But as for me, I can collect like terms to this side. It's gonna be 1 over 2x minus 1 over 4x, which is equal to minus 35 to this side is going to be a positive 35. So that's 1 over 2 minus 1 over 4, which is 1 over 4x is equal to 35. So in order to find x, you can just multiply by 4 like this. So this is going to cancel. You remain with 1x, of which 1x is x. So 35 times 4, which is 140, like this. So x representing whose amount? Peter's amount. So we are saying Peter originally at 140 rand. So what I'm trying to say is that this question does not make sense. Now let's put it this way. If we find 1 over 4 of that amount, like if we multiply 1 over 4 times 140, because that is the amount for Morris, this one. So 1 over 4, if we multiply this one by 1 over 4, this one is going to be 35. You are going to obtain 35 rand. And ayanda it's half, and if you multiply this by half, you are going to obtain 70 rand, like this. So the part that I want you to see that it doesn't make sense is this part. Look what they said. They said ayanda received 35 rand less than Maurice, which means we are saying the amount of ayanda is the one which is less than the one for Maurice, of which this is opposite. The Maurice amount is the one that is less than the one for ayanda. So this statement was supposed to be ayanda received 35 more than Maurice here, so that it can work here. Ayanda received 35 more than Maurice, more than. That is where you're going to apply this concept. The reason why I didn't use the less than the actual statement, this one, is because if you work out, it's going to give you a negative, and that one is not going to work. So it was actually a wrong way that was done here. This one does not make sense here. All right, anyways, on 3.2, they asked to solve for x, and we are given that equation, which is on 3.21, which is a 2x minus 1 over 3, which is equivalent to x minus 1. So actually, for you to solve this, you can just cross multiply, because as you can see, you can write this as a fraction. So you can just multiply the 2, that's 1 multiplying 2x minus 1, just open a bracket, 3 into x minus 1, like that. So it's going to be 1 times 2x, which is 2x, 1 times minus 1, which is minus 1, 3 times x, that's 3x, 3 times minus 1, which is minus 3. So collect like terms, gonna have minus 1, this one to this side is gonna be plus 3, which is equivalent to 3x. Transpose 2x to that side is gonna be minus 2x. So minus 1 plus 3, which is actually 2, and 3x minus 2x, which is 1x, and which 1x is same as x. There's no need for you to write it as 1x, guys. 1x is same as x. All right, so that's what we had. And on 3.2, we asked to solve. So as you can see there, the quadratic equation, so we can just maybe rearrange that one. We've got 32x squared minus 8 is equal to 7x. Remember the format of the quadratic equation, that you are supposed to leave one of the sides equal to 0 there. So we have to transpose 13x squared. If we transpose this, it's going to be minus 7x minus 8, which is already there, is equal to 0, like that. So if you are to apply the quadratic formula, remember your quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. All right, that's your quadratic formula there. So that's our a, our b, and our c here. So you're gonna have minus a, which is minus 7, so just plus 7, so it's gonna be minus and minus. Take note, minus and minus, it's plus 7 there, plus or minus the square root of b squared, which is minus 7 in a bracket squared, minus 4ac. Our a is 13 and our c is negative 8. All right, everything over 2a, which is 2 times our a, which is 13. All right, of which you can just simplify further, because this is going to be 7 plus or minus the square root of. So what I want you to is to simplify this part under the square root, this part here, which is going to give you 465. So that's 465 over 2 times 3, 13, which is 26. All right, so you can now separate this, start with a plus, 7 plus whatever that you're going to have with a plus, and this is going to give us 1,09. Make sure on your calculator is like this. You have to have this like this, square root of 465 over 26. So you make sure the division covers everything like this. All right, so you're going to obtain 1,9896, something like that, or another x is going to be minus 0, when you put a negative, so you just interchange to a negative, which is going to be negative 0,56 0.0148, yeah, something like that. So remember the degree of accuracy to 3 decimal places, 1, 2, 3. So this is gonna change into 9. So it's 9, 9. Our x is equal to negative 0.123. So this one cannot change this 0, so it's just gonna be 5, 6, 0 like that. So that is the values of x. The values of x from that quadratic equation. So it was a matter of rearranging the equation, then solving whatever way that you be given. All right, then we are given the angular velocity of a flywheel is 272 rad per second. So remember the angular velocity, that is your omega. So you are given omega is 272 rad per second, like this. So this is just a Greek name omega, which is the angular velocity. So the first question 3.31 is to calculate the rotational frequency, which is n. So actually we know that omega is equivalent to 2 pi n, which is n in revs per second, which is our rotational frequency. So we can play around with this to make n the subject, since we have got this. So we can divide by 2 pi by 2 pi. So that's n is equivalent to omega over 2 pi, which is our omega, which is this 272 over 2 pi. All right, so and this is gonna give us something like 43 comma something like that. That's gonna be 43 comma 290144, something like that, which is 43 comma 123, which is 2902 in revs per second. So that's gonna be our n in revs per second, which is the rotational frequency. All right, then the circumferential velocity, this is the actual velocity, which is actually measured in meters per second, but we are given the radius here. So we know that the circumferential velocity is given by the formula of v, which is v is equivalent to pi dn. So v is equivalent to pi dn, where this is the diameter in meters, and that is our rotational frequency in meters, in revs per second actually. No, revs per second, yes, that is in revs per second. This is our n. Okay, we've got our n here. All right, so we said this is we need the diameter here. So remember, we've got the radius, which is also in centimeters. So diameter is equivalent to 2r. So it's 2 times radius, which is 2 times 3, which is 6 centimeters. So we have got a diameter of 6 centimeters, which is in meters. It's we divide by 100, which is 0.06 in meters. So make sure that you just divide properly. I wonder why I'm not using a calculator, but that's it. That's your D. So now the V, which is the velocity, is going to be pi times D, which is 0.06 times the n, which is the n we obtained it here, and the rotational frequency, which is 43 comma, so we have got this one 43 comma, just write it as it is 290, like that. So that's gonna give us the velocity in meters per second, which is 8,159,972, something like that, which is 123. So as you can see, 9 is going to change this into 10, and this gives us this one into 6. So it's going to be 8,160. All right, so that's our velocity, and this is direct velocity, tangential velocity, or circumferential velocity, which is measured in meters per second. So that one is in meters per second. Then we have got the angular displacement in radians after 5 minutes. So you're given time in minutes. So all right, how are we going to have this one? We're given the time in minutes, which is 5 minutes. Remember actually that we have got this formula where we say theta is equal to omega over t, which is velocity over time, because omega is theta t, so theta is omega over t. All right, theta omega is the one that is, so guys, hey, pardon me please, this is now, the mind is tired. Theta is over t gives omega, so because it's the change here, all right, so we can cross multiply, which is theta is equal to omega t. Now it makes sense. Remember guys, the angular velocity here, we have it omega, which is 272. So we've got 272 times the time, and this time must be in seconds. So what are we going to do here? We are given time in minutes, so we've got 5 times 60, which is 300 seconds. Why? Because remember, in a minute we've got 60 seconds, we've got to multiply by 60. So if we multiply by 300, we are going to have our theta now exactly, which is 81600 in radians. So this is just rad, so this is actually in radians. All right, so that's how they ask these questions. So that is our angular displacement in 5 minutes. Then on 3.4, calculate the area of a sector with radius 2,8 centimeters and an angle of 45 degrees. Because that theta is supposed to be in radians, so we just need to make our conversion there. Remember, a sector, I've got something like this, guys. That's a sector. So remember, that's your radius there, which is 2,8 centimeters. All right, then we have got an angle here which is supposed to be in radians, so you have to change this to radians. Remember, theta in radians is equal to theta in degrees over 57,3. This is your theta in radians. So our theta in radians is going to be theta in degrees, which is the 45 degrees, this one that we are given. So it's 45 degrees over 57,3. So it's best for you to have your theta in radians. Definitely you have to use it in radians, which is going to give you 0.785 rad, something like that, to 3 decimal places. All right, so the question here is to calculate the area of the sector. So the area, if we are given this our area, remember area is equivalent to half r squared theta. So it's going to be half times r squared, which is the radius squared. So that's 2,8 squared times theta in radians, which is this theta in radians, 0.785. All right, so that means we have to just use your calculator properly, which is going to give you 3,0772, which is 3,077 square centimeters. Remember, that was area, and area is measured in square units, like that. All right, so that's what we had. And the other question was to convert the question to radians. So this type of a question, actually, since we know that theta in radians is equal to theta in degrees over 57,3, which means you have to convert this to degrees first, then we can convert to radians. So this is how you do it. That is 45 minutes 54 seconds, like this. Okay, so first let's convert these seconds into minutes. Okay, we know that in a minute we have got 60 seconds. So what about 54 seconds? How many minutes are we going to have? So we just divide by 60 there. So if we divide by 60 by 60, 54 divided by 60, which is 0.9 minutes. All right, so these are minutes. So you can now add them to 45. So you're going to have 68 degrees, 45 minutes plus 0.9 minutes, which is going to give us 68 degrees. 45 plus 0,9 is gonna give you 45,9 minutes. So since, remember, we want to end up in degrees, so you have to convert this to degrees. How do you convert? Remember, in a degree we have got 60 minutes. So what about 45,9 minutes? How many degrees do we have? So we just divide, just like what we did there. So it's 45,9 divided by 60 times 1 degree. So it's gonna be in degrees now, which is 0.765 degrees. So this is now in degrees. So we can add it to 68 degrees now, which is 0.765 degrees. You add to degrees, which is gonna give you 68,765 degrees. All right, but we are saying that this is supposed to be in radians, but now it's easier for us to convert to radians because we have a relationship between degrees and radians, which we said theta is going to be theta degrees over 57,3, then it will be in radians. So your theta in degrees is this one, 68,765 degrees over 57,3. So the moment you do that, you're going to have your answer now in radians, which is 1,200,8726, something like that. So to 3 decimal places, 1, 2, 3. This 8 is going to change this 0 into 1, so it's 201 rad. So this is now in radians. So guys, as you can see, that's how they can just ask these questions and how you are supposed to attempt such typical questions. You have to be very, very careful with the question that you'll be given, so forth. Then the other question, which is actually on question 4, calculate the area enclosed by the curve passing through the following points. Okay, so this one is direct, guys. Remember that the values of x, this one 0, 3, 6, 9, they give you an interval. So that's an interval, that's 3 minus 0, which is 3. So there's an interval of 3. So remember how you calculate your area, guys. Let me just show you from your formula sheet. Maybe it's gonna make sense if we have this from our formula sheet. All right, this is it here. Your area is equivalent to the first ordinate plus last ordinate over 2 plus sum of the other ordinates. So these ordinates are the values for y. You add the values for y, okay? So the first ordinate is this one for y. It's, remember, point is x, y. So your first is 4 and your last one is 7 for y there. So that's 4.1. So your area is going to be, first ordinate, we said it's 4 plus 7, okay? So that's 4 plus 7 over 2. That's first plus last ordinate, okay? Plus sum of the remaining, you add for y only. So for this point, you take for y. So it's 6, 8, 10, 8, okay? You take the values for y only. So it's 6 plus 8 plus 10 plus 8, like this. All right, so this is what you have. The values of x, like I said, they give you the interval. That's why you see there is same difference, 0, 3, 6, 9, 12, 15. If you subtract 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3. So that is the interval that you're going to multiply with. So you multiply by 3. So a is equal to, so you add 4 plus 7 divide by 2, which is going to be 5,5. Then you add everything, 5,5 plus 6 plus 8 plus 10 plus 8, which is going to give you 37,5 times 3. So that's your area. If you multiply this, it's going to be 112,5, which is measured in square units. So you can write this as square units like this, or just in short as square units like that. So that is your area. Then a soccer ball is a diameter of 280 millimeters. Calculate the volume of the soccer ball. Take note in cubic centimeters. So the first thing is we can change that to centimeters because we need it in cubic centimeters. And remember, in a centimeter we've got 10 millimeters. So you divide by 10, 28 divided by 10, 280 divided by 10, sorry, which is 28 centimeters. But this is the diameter. And if you are to calculate the volume, this is a soccer ball, which is a sphere. And a sphere, we know that the volume of a sphere is 4 over 3 pi r cubed, of which you are given this. So we need the radius. From the diameter of 28 centimeters, the radius you divide by 2. That's now your radius, which is 14 centimeters. Take note, we need in cubic centimeters, so you have to work with centimeters. So that's going to be 4 over 3 times pi times 14 to the exponent of 3, which is our radius, this one. So you just substitute into your formula, then you use your calculator. This is going to be 11494,04032, which is actually 11494,123 to 3 decimal places, which is the volume. And this is now in centimeters, because we are working in centimeters, so it's now in cubic centimeters. That's our volume. So that's what we just needed there. Then another part is given that cos beta is 0.5, calculate the possible values of beta between 0 to 360. Okay, so remember this one, you just need to calculate the reference angle, then you state the quadrant, because this is cos beta is 0.65, which is a positive. So which quadrant are we talking about? From all students take calculus where cos is positive. So cos is positive in the first and the last quadrant. So you're going to find the reference angle, which you find by arc cos of this decimal, which is arc cos 0.65. So you find the reference angle, of which arc cos 0.65 gonna give us 49,4583, something like that, which is 49,458 degrees. So since the first angle is in the first quadrant, and remember guys what I told you, that in the first quadrant the reference angle is equal to the angle that you have in the first quadrant. So that means our beta is going to be 49,458 degrees. And another one in the third quadrant, remember this is, you subtract from 360, so it's going to be 360 beta. Okay, let me just put it here. Beta is equal to 360 degrees minus the reference angle. So you subtract the reference angle, which is 49, something like that, and this will give us 310,542 degrees. So that's another beta. So as you can see, these are the two possible values depending with the quadrant where cos is what, where cos is a positive. You are working with the quadrant where cos is a positive there. All right, a rectangular shaped bronze, a block of bronze with length, you are given length, breadth, and the height in millimeters, is melted into a circular sphere. Calculate the diameter of the newly formed circular sphere. So what's the relationship between this? If you melt a rectangular prism to a circular sphere, the two, they are going to possess the same volume. All right, so we are simply saying the volume of a rectangular shaped sphere, which is equivalent to LBH, and the volume of a sphere, which is in this case this one, is melted to form a circular sphere, which is 4 over 3 pi r cubed. So these two, they are equal. So what we are going to do is to simply say LBH is equal to 4 over 3 pi r cubed. So you can take advantage, since here we can calculate the volume because all the dimensions are there for the rectangular shape. All right, so our LBH is going to be the length of 5, breadth 3, and 4. So it's 5 times 3 times 4. Okay, which gonna give us 60 cubic millimeters. Remember, these were in millimeters, so we are going to have 60 cubic millimeters. And we are saying that the volume of the rectangular prism, this one, is equal to the volume of the sphere. Since we want the diameter, we know that diameter is 2 times radius, so we are going to calculate the radius first, then we can calculate the given diameter. So in this case, we are simply saying the volume of the sphere is equal to the volume of the rectangular shaped box, which is 60, and this they are equal. So 4 over 3 is equal, 4 over 3 pi r cubed is equal to 60, like that. So we are going to calculate r, then diameter is there, and take note our answer is going to be in millimeters also. So how can we do this? We just have to play around with the formulas. So what we can do is to maybe just cross multiply, because this is 1 times 4, which is 4 pi r cubed, which is equal to 3 times 60, which is 108 there. So you can divide by 4 pi both sides. So that's gonna be r cubed is equal to, if we divide by 4 pi by 4 pi like this, so this is gonna cancel, which is r cubed, it's 180 over 4 pi. So we're gonna have 180 over 4 pi, and this is to the exponent of 3. So to remove that, you introduce the cube root. Okay, you introduce the cube root on both sides, so that's gonna cancel automatically, which is r is equal to the cube root of this from your calculator, which is gonna give us 2,428,590, something like that, which is to 2 decimal places, to 3 decimal places, I mean. That's 1, 2, 3, 5 is going to change this 8 into 9. All right, and remember that was cubic millimeters, so this is going to be in millimeters, which is the radius. But the question is not asking about the radius. We want the diameter there. So the diameter is going to be the product now, which is diameter is 2r. So it's 2 times 2,429 millimeters, which is going to give us 4, so this is going to be 4,858 in millimeters. So this is the diameter of the newly formed sphere from that question. All right, then on 4.5 we are given a man standing at a point A finds that the angle of elevation of a nearby tower, there's a tower there, which is 65 degrees. So there's a tower like this, it's a vertical, and there's an angle of elevation of what? Of 65. When he was at a point A, looking at the top, this is the top of the tower, and the angle was found to be 65 degrees at a point A, then that is it here. So definitely this is a horizontal line, this is a vertical line, so it's going to be at 90 degrees like that. Then the person walks a distance of 280 meters to B, the base of the tower. So B is the base. Remember, this is the top and this is the base, so this is the point B. So you can just say the top at C like that. Since so this is 280, the distance which was moved from A to B, which is 280, which is the base of the tower. So determine the following: the height of the tower, that is 4.51, the height of the tower. So take note, this is the height of the tower, this one. So since we just completed this as C as a right angle triangle, we can just use to calculate BC to represent the height of the tower. And which part are we going to use? So what you're going to name is to name according to this angle of 65. As you can see, this is your opposite, and we have got 90, and this angle, this is your adjacent. So there is only one ratio, actually only one ratio, which uses opposite and adjacent. So what you just need is to locate that ratio from the mnemonics for SOHCAHTOA this one. So there's only one ratio, as you can see, with opposite and adjacent, which is this one for tan. So it means tan theta is equal to opposite over adjacent. That is opposite over adjacent, which is tan theta. Your theta in this case is 65. So tan 65 degrees is equal to opposite, which is the side that you want to calculate, this one, which is BC, over the adjacent, which is the adjacent, which is your AB, which is 280, which is adjacent, which is AB, like that. So definitely you can calculate our BC, which is the height, by cross multiplying 1 times BC. That's BC is equal to 280 times tan, which is 280 tan 65 degrees. So 280 tan 65, this is gonna give us something like 600, something like that. So make sure that you use your calculator in degrees there. So it's gonna give you 600, 46193, something like that, to 3 decimal place, which is gonna be 600, 462. And the units, the other part there, remember it's meters, so this one is going to be also meters. So that is the height of the tower. All right, so we've got the height of the tower. Then another question is the distance from A to the top of the tower. Okay, so from A here to the top, which means we are now moving this way. So this is AC. So this AC is the hypotenuse. So according to what we had the adjacent before and the hypotenuse. So which ratio? This time it's cos. Okay, remember cos theta is equal to adjacent over hypotenuse, which is cos theta, the angle of 65 degrees, is equal to the adjacent, which is 280, over the hypotenuse, which is the one that you want to calculate, which is the AC. So that means to find AC, you can cross multiply and do whatever that we can. If you cross multiply here, it's going to be AC cos 65 degrees, which is equal to 1 times 20, which is 20. So to find AC, you're going to divide by cos 65 by cos 65 here. So you're going to cancel this. That's AC is equal to 20 divided by cos 65, which is going to give us 662,536. Okay, 443, something like that. So which means your AC is going to be 662,536, like this, comma here, which is actually in meters. So that's your AC in meters. So guys, very take note of your working, the way you're going to present your working and so forth. Please take note about that. Okay, so on question 5 we are given a graph of y is equal to okay, this was actually 8 marks, guys. Take note, sorry for that. And the question 5, you've got y is equal to x squared plus 6x minus 7. So first question on 5.11 is to find the roots, which is the x-intercepts. So remember, x-intercepts are on a condition where y is equal to 0 in the x-axis. Okay, y is equal to 0. So when y is equal to 0, it means we are going to solve this equation. That is x squared plus 6x minus 7 is equal to 0 in place of y, like that. So you can actually do this by factorization, which is remember, we need the factors. Of course, here we've got the coefficient of x squared, which is 1. So what are the factors of 7, which gonna give us 6? 7 and minus 1. If we multiply, that's minus 7. If we add, that's 6. So it's plus 7 minus 1. So our x is going to be plus 7 to the other side is minus 7, or minus 1 to the other side, which is a plus 1. So x is equal to minus 7 or plus 1. Okay, that's what we had. Then we have 5.12, the axis of symmetry. So the axis of symmetry, remember, it's on a condition where x is equal to minus b over 2a. That is the equation of the axis of symmetry. So we're gonna have 5.12, which is x is equal to minus b over 2a, which is from this part you've got a and b, a, b, c. So your b is 6 and your a is 1. So it's minus b, which is minus 6 over 2a, which is 2 times 1. Remember, x squared plus 6x minus 7 is equal to 0, like that. So this is your a, your b, your c. So a is 1. So which means our x is going to be minus 6 divided by 2, which is minus 3. So x is minus 3. All right, then the turning point, remember the turning point, it's on a condition where x is this value of the x of symmetry, and the value of y, you just substitute it into the original value of the equation. So which means on 5.13, already the value of x at turning point is the one at the x of symmetry, which is x is minus 3. So y is going to be, you substitute minus 3 in place of x here. So it's minus 3 squared plus 6 into minus 3 minus 7. So this will give us minus 16. All right, so therefore our turning point is going to be x minus 3 and y, which is minus 6. Remember, a turning point is supposed to be made of x and y. So I think I explained some of this concept about the turning points and so forth on separate graphs. So make sure that you watch the video so that you can understand much more about these typical questions. Then the y-intercept, remember the y-intercept in the y-axis, x is equal to what? X is equal to 0. So you can just take that as an advantage to say x is equal to 0. So if x is equal to 0 here and here, which means y is going to be minus 7. So y is minus 7. So y-intercept, that's 0 minus 7, or just minus 7, like that. All right, so we have all this information, guys. You just need to revise along the line so that you'll be able to understand what's going on there. And on the other part, you're now asked to draw that part on a graph paper. Okay, so guys, actually that scale and what it's going to look like on the graph paper, guys, is going to be something that is very, very weird. So I'm just going to put it on a sketch because it's going to be something weird, guys. But you have to do it on your graph paper, this part here. But what is important on your graph paper is to represent these values here that we were calculating. The x-intercept, remember we calculated the x-intercepts, all those solutions, and so forth and so forth. So those are the ones that you are going to take into consideration. Remember our x-intercept was at minus 7. Was this the one, guys? At minus 7, and the other one at 1. Yeah, the other one was at 1, the other one at minus 7. So you can have 1 here and minus 7, which is somewhere here. Yeah, so you just make sure that you mark your points properly, then the y-intercept and so forth and so forth. So, and also the shape here is a positive, so it's gonna be something like this, ever positive. So which means it's gonna be something like this. Yeah, here is the point 1 here, which is important on your axis, okay? And this point, which is the y-intercept, remember your y-intercept and the turning point, your turning point was at minus 316. So this point must be at 16, guys. You see the scale, there is something very, very weird. So this will be your turning point, and this will be your y-intercept. And our y-intercept, guys, what was y, which was minus 5, minus 7 or minus 5? That was minus 7, something like that. Okay, so you just need to sketch them. And also the straight line. So the straight line, remember, guys, you have to use the points where x is equal to 0. We know that y is minus 3, which will be somewhere here. And when y is equal to 0, x will be equal to 1,5. When y is equal to 0, x is going to be 1,5, which means somewhere here at 1,5. Then you join. So make sure that you just join your points properly. This one is at a point when x is 0, we said y is minus 3, and here is 1,5. So this is the line of y is equal to 2x minus 3. So that is what you are supposed to have on your graph. So make sure that you put it nicely on your graph. Then the point of intersection is where these two graphs are going to intersect. So you're going to take the value of x and y at this point and also the value of x and y at this point. That is your point of intersection. All right, so that's what you're gonna have there. Then draw the graphs of these graphs on the same set of axes, the following functions: f of x from 0 to these functions. So remember, when we are to draw these typical trig functions, I told you guys it's best for you to have a table that you're going to follow there. So the first one is f of x. Okay, f of x is equal to sine x, and we are given an interval from 0 to 360. That's 0 to 360. So mostly it is best for you to separate with 90 degrees. Okay, so that is what is best for me, guys, to separate this by 90 degrees. So it's x and y there. So you've got 0 degrees, 90 degrees, 90 plus 90, which is 180, 180 plus 90, which is 270, 270 plus 90, which is 360. So you add up to 360 there, from 0 up to 360, separate by 90. That is the best step that you can do. So as you can see, it's degrees, so make sure that your calculator is in degrees. Make sure you substitute properly. Sine 0 is going to give you a 0. Sine 90, that's 1. Sine 180, that's 0. Sine 270 minus 1. Sine 360, that's a 1 there. So you can actually have it like this. So that means, so this one, we are just going to mark our points here. We are going to mark our points here, which is that's 0 versus 0 here, which is at this point. Let me just use another pen, which is at this point here, 0 versus 0. Okay, then 90 versus 1, that's 90 here versus this one. So 90 versus 1, where these two meet, you just join those points. All right, then it's 180 versus 0, which is 180 versus 0. You mark it direct at 180 there. All right, at 180. Then 270 versus minus 1, so it's 270 and minus 1, where these two meet, you mark a point. 360 versus 0, which is here. So these are the points that you are going to join. This one, so you just make sure that you draw a smoother curve. Yeah, just draw a smoother curve. Yeah, so that's what I'm gonna have. That's what I'm having here. I don't know if it is clear. If I do this, it's not going to be nicer, guys. This one is not going to be nice if I do this, but anyways, that's what we're gonna have. So this is our f of x. Okay, that's our f of x. Then we need gx, which is 2 cos x minus 0,5. So you just do the same. You have your table here. This time we just have our table. Gx is equal to, that was 2 cos x minus 0,5, like this. So make sure you just use the same values of x and y, just like the ones that we had here, which is 0 to 360, 90, 180, 270 here, up to 360, like this. All right, so make sure that you substitute properly. This on your calculator is supposed to be like this: 2 cos 0, like this. You close that bracket, then minus 0,5, this one. Okay, that is what you calculate. 2 cos, you move on to 90, like this. You close that bracket, then minus. This is what your calculator is supposed to, what exactly is supposed to be on your calculator, like this. All right, so the first one at 0 there, we are going to obtain, let's just do it here. As you see now, these values of writing them down. Okay, so here I'm obtaining, that's 1,5. So let me just, okay, here 1,5. So make sure you put it nicely. 90, 2 cos 90, like this, minus 0,5, which is going to be minus 0.5, then 180, you do the same, you put 180, which is negative 2.5. So you're gonna do this up to the last value, which is negative 0.5, 1.5, like that. So these are the points that you're going to mark now on that graph. Remember, they said on the same axis, so you're going to use the same axis here to mark those points. So the first one is 0 versus 1.5. So 1.5 is just in between 1 and what, and 2. So 0 versus 1.5, which is here. That's our 1.5 here, in between 1 and 2. Okay, that's in between. Then 90 and minus 0.5. Is that so? 90 and minus 0.5, guys. I do. This one is 1.5. Okay, let's just do this. 90 minus, because this is minus 0.5 here, in between 0 and minus 1. That's somewhere here. So you just mark properly your point. 90 versus in between. Okay, then 180 versus minus 2.5. 180 minus 2.5. This is minus 2. Minus 2.5 is in between minus 2 and minus 3, but it's versus 180, which is 1, 2, somewhere here. So you just mark in between those 2 points. Make sure the boxes are in between 180 and this one. Then it's 270 versus minus 0.5, which is 270 minus 0.5, that one again that we had before, which is somewhere here like this. Okay, then 360 versus 1.5. 360 versus 1, the one that we had here on top there. So I don't know, it's gonna be 1, 2, 3, 4, somewhere here. Yeah, somewhere here. So guys, make sure that your sketch is very, very neat and clear. So you have to join. It's supposed to be like this, from this point to 270 at minus 1. It goes at this point. Okay, here is supposed to be like this. It goes that point, curve like that, something like this, guys. All right, so this is what it was supposed to look like, and this is our gx here. This is our gx. So that's our gx like this. Let's just see if it's gonna make sense, guys. So now you see, when you do it like this, now it's now going to affect the other values, but it was supposed to be like that. All right, then I don't know if it is clear, guys. I don't know. From the graphs drawn in this, for which values of x is f of x equal to gx. So the values of x for which these are equal is at the point, these are the points of what, of intersection. The points of intersection where these two graphs meet. Okay, so at the point of intersection here where they meet, you're going to take the value of x at this point. Then also here they meet at this point. So now, guys, as you can see, this is not clear enough, but you're going to take the values of x there. So you calculate the value of x which gonna correspond to that point. That is the one that they are asking there, which is point of intersection. So as you can see, guys, that's what we needed to have a total of 100 for this question paper. So what we need, guys, is to actually work on more question papers, revisions, question, and whatever sources that we can use to prepare for the exams which are ahead of time. So that's it, guys, from Meson African Motives. Till we meet again.